Hey, Jeff Disher here again. Today I'm going to talk about some units and terms that I end up using in some of these talks to make sure that they're well understood and explained. Hopefully I won't get too dry, but I think it's worth just kind of quickly stating these things. So first of all, in units, we talk about hertz a lot. That's something that usually you're probably used to hearing this in terms of things like, well, your CPU is 2 gigahertz or something. Well, 1 hertz is a pulse per second. So 2 gigahertz would mean 2 billion pulses per second. So it tells you how quickly things are happening that are sort of a periodic basis. You also hear about this when you're talking about like your cell phones, communication frequency as well. That's for different reasons. But the same term shows up because it's just talking about something which happens every so often. It's a periodic measurement. A byte, of course, we all know that's 8 bits. The history behind this is more complicated, but for quite a while now we've been using 8 bits everywhere for a byte. So that's always what I'm referring to. A bit, for those of you who don't know, the basis of this term is binary digit, just kind of shrinking those two words together. This is because a bit can have exactly 2 values. It can either be 0 or it can be 1. So one binary digit. Kilo, this is of course the prefix for 1,000 in metric and SI. So similarly, this means all the SI units like kilobyte, megabyte, things like that. These are all multiples of 1,000. So this goes on. There's kilo, mega, giga, tera, right? 1,000, million, billion, trillion. And this goes on from there. But this is kind of the spread that you're going to see in modern use. But yeah, those are always multiples of 1,000. Now this, of course, brings us to the next point of, well, okay, but I've heard before that a kilobyte is 1024 bytes. It's like, actually, it's not 1,024. Kilo means 1,000 in all different sorts of units, not just the ones used by computers. And even in the original Greek, it means 1,000. So this brings us to our SI units versus binary approximation units. So computers work in binary, base 2. But humans tend to use decimal, or base 10. Now, a round number in decimal, like 1,000, is not necessarily a round number in base 2. In fact, the closest round number in base 2 is 1024. And historically, what this meant was computers can, like humans, computers work faster in numbers which are sort of round within the number system. They have certain properties that make it easier to work with them. Historically, this meant that computers could work much more efficiently. In fact, some couldn't work at all with numbers that weren't round. So it meant that, well, 1024 and 1,000, they're close enough. And 1024 is one we can actually work with, so we'll use that. So the International Electrotechnical Commission tried to solve this problem in 1999 by creating a bunch of new terms to say, okay, well, kilo will be 1,000, but we'll have something different because it's 1,000 everywhere else. But we'll have something different for these binary approximations, the 1024 and the corresponding megabit approximation and things like that. So what this started with is, at the lowest terms, these go all the way up for kilo, mega, giga, tera, all the way up. But I'll just focus on the ones around kilo. So kilo is 1,000, so what they came up with was something called kibi, the kilo binary approximation. So kilo and binary, squish them together, you get kibi. So 1024, that means kibi. When you see this written, you'll have like a kilobyte will be like a low k, large b, right? That means 1,000 bytes. Kibibyte will be a large k, little I. So ki, and mebibyte is like mi, and so on. And these mean the 1024 bytes in this case. So usually, though, we're kind of moving away from that just because there's no longer any reason for computers to have to approximate things in binary in 1024. We can just use 1,000 directly now, so we may as well. So other terms, just some background that I wanted to take down. There's things like the CPU, right, the central processing unit. This is the part of the computer which actually interprets the software that you load into it. It executes the sequence of instructions represented by a program and does whatever's required. And that's what you interact with and how you use a computer. There's memory, or RAM, random access memory is historically what it stands for. The reason to distinguish this is sometimes when people refer to memory, they might be meaning the underlying storage, the persistent storage in the system. I just wanted to say that whenever I'm referring to memory, I'll be talking about the in-memory, the fast, where operations are being temporarily stored and performed. When I'm talking about storage, I'll be talking about storage, which is, of course, the persistent data storage where you put finished results and things like that, and where software is loaded from when it's being loaded into memory. Now, this could refer to a hard drive, a solid-state device, a network storage, cloud storage, anything like that. They work kind of the same way from the point of view of most of these conversations. Hard disk, of course, the historical way we always stored data, it was literally a hard disk of material that had magnetic signatures read and written to it. So those still used today, of course. They're cheap, large capacity. We have them in most of our computers. Of course, they're starting to be replaced by something called SSD. Now this means a solid-state device. And really, this is like building a really big version of the memory cards you put in a camera or a phone. Works on a very similar concept, but there's just more of it. So you can store data that way. The reason for this is these are actually more reliable because they don't have any moving parts. Also, they're much faster because since there's no moving parts, you don't have to move any of the parts to where you need them. You just access the data and it very quickly comes back. So they're very reliable and very fast, but they're very expensive. So that's why it's taken so long for them to take off. But we're starting to see them show up now. Multi-core is something that started to become popular a few years ago. And the reason for it is that as we got better at making CPUs smaller, they used to always get faster when we did that too, and after a certain point they stopped getting faster. But we could still make them smaller. So the better way to make use of that extra space we now have is to put more CPU cores, the actual part of the CPU that does the thinking. We'd put more of those cores on one physical chip. So now you end up with buying a computer, it probably comes with a 4-core processor. From the point of view of your operating system, it thinks you've got 4 CPUs. The distinction between them is very small, and it doesn't really matter for these terms. Also, there's a term I use sometimes, which is kernel. What I'm actually referring to is that's the term given to the lowest level part of the operating system itself. That's what actually, everything is running on top of that, the operating system kernel. So you'll see this term come up sometimes when people are talking about operating systems, or when I'm referring to it, but it really just means the operating system. Also, source versus binary. Sometimes I try not to use terms like this in these conversations because I think they're just confusing. But if you ever talk to a computer programmer or even a Linux user, they'll often refer to the difference between getting a program as source versus binary. Source means that's the computer's source code as written by a programmer. The binary, that means the finished packaged version of the program which is ready to be loaded onto your CPU and executed as software. Most people only ever get software in binary form, and so they're just referred to as programs. But sometimes you hear people use one or the other, and sometimes I end up calling a program a binary just out of habit. But I'm just referring to the program. So that should give us kind of clear up any small misconceptions surrounding some of the things I talk about a lot in these. But yeah, as always, anything that you want to, any questions or comments or suggestions, feel free to contact me. I'd love to hear from you.